Hi everyone, it's Matt with AUB. Let me chant the good slogan. The great my spiritual guide, fly me some strength. Let's see and find out our question number 1. Root 13 square minus 12 square. Root 13 square minus 12 square is equal to nth root of 125. Is equal to nth root of 125. Find n. Find n. Let me write the question for you again. 13 square minus 12 square is equal to nth root of 125. Nth root of 125. It is given to us. We are interested in the value of n. In the value of n. 13 the 169. 12 the 144. 169 minus 144 is equal to n times 125 can be written as 5 times 5 times 5. 169 minus 144, the result is 25, and here we have nth root of 5 raised cube, 5 raised cube or 5 cube. This is the index. It can be written as 25, 5 times 5, and this one can be written as 5 raised 3 over n. 3 over n. This one. If nothing is there, then it's tantamount to 2. Otherwise, whatever is present here, we have to write in denominator. There is an, I have written 3 raised 3 divided by n, 3 divided by n. 5 is already there. We have factorized 125 as 5 times 5 times 5. 5 cube, that's nth root. I have written 3 over n. There is a pair of 5. 5 is equal to 5 raised 3 over 8. 1 is always there. Bases are equal. Equal sign. Equality symbol prevails. Bases are equal. Therefore, powers are equal. I have 1 is equal to 3 over n. Switch n from division to multiplication from right to left. I have n is equal to 3. N is equal to 3. So, our value of n is 3. Or one can adopt a simple strategy by factorizing this one, like difference of 2 square, a minus b, a plus b. Then it is going to be simple enough. Let's see how. Let me erase this first. One can adopt this approach as well in order to avoid calculation. 13 plus 12, 13 minus 12, and I have 125 raised 1 over n at the start, at the outset. 13 plus 12, that's 25. 13 minus 1 is 1. I have factorized of 125. 5 times 3, 5 into 5 into 5. 5 into 5 into 5, 310 times 1 over n. 25, square root of 25. Okay, let me write for simple u. 3 over n. 3 1 the 3 over n. 5 square means only 5. 3 over n. Bases are equal, therefore powers are equal. 1 is equal to 3 over n. Or switch n here, n is equal to 3. N is equal to 3. N is equal to 3. Not a simple strategy. By factorizing difference of 2 square, or you can multiply 169 minus 144, whatever the case is, you are going to arrive at the same results. Or one can verify from the options. If I put 1 here, it is not make sense. It doesn't make sense. At least value of n must be 2. Value of n must be 2 or greater than 2. 2 or greater than 2. 2 or greater than 2. Here I have, if I put 2 here, 2 means no need to be mentioned. If value of n is 2, no need to be mentioned, it's 125. Root of 125 is 5 times 5. 5 times 5. And here we have only 5. So our option 2 doesn't work. What about 3? Put 3 in that case. I have 3. 2 cannot be mentioned. 2 to be mentioned. 125 raised 1 over 3. Cube root of 125 is 5. And the result of this one is also 169 minus 144. One can easily verify. 25 means 5. That is. One can verify by utilizing the options. It's up to you. Simply calculate, apply difference of two square strategy or whatever suits you. Just do that. Let me push myself towards question number 2. It's mentioned that we have given a linear function f of t is equal to 7 times t plus 12 for what value or values of s, values of t. For what value or values of t, f of t must be greater than 33. We are interested to hunt the values of t that give f of t greater than 33. F of t is greater than 33. Simply how to solve inequality? One is easily familiar. What is the value of f of t? 7 times t plus 12. 7 times t plus 12 is greater than 33. As we have mentioned, solving for t, 70 is greater than 30. Switch over positive 12 from left to right as negative. 7 times t is greater than 21. Dividing by 3, t is greater than 21 over 7. So t is greater than 3 is our option in that case. Option number 8 suits us. One can verify by putting the values as well. T is greater than 3. T is greater than, I am taking 4. 7t plus 12 must be greater than 33. As we have mentioned, 7 times t, t means 4. T greater than 3, greater than 3, I have taken 4. I have taken 4, 5, whatever the case is. Plus 12, greater than 33. 7, 4 are 28, 28 plus 12, it will become 40, obviously. 40 is greater than 33. 40 is greater than 33. We are done with this question as well. Moving towards question number 3. Moving towards question number 3. That is simplify to the lowest term. Simplify to the lowest term. It is y square minus 5y overall, y square minus 4y minus 5. Simply factorize. Y is common factor in the numerator. Y is the common factor in the numerator. What about denominator? It is trinomial type. Middle term breakup. Trinomial. 1 5 the 5. 1 5 the 5. If I subtract minus 5 plus 1, minus 5 plus 1, it results in negative 4. Negative 4. Let's see how. Taking y common from the numerator, y common, y minus 5, applying middle term breakup technique, y square, by utilizing the factors of first and last, by utilizing the coefficient of factors of first and last, we have to manage the middle term 4y. I can write minus 5y plus 1y minus 5. Look at this. I have broken down the middle term. I have broken down the middle term by utilizing the coefficient of the first term and the last one and making the middle one. Y times y minus 5, taking y common from the first pair, it results in y minus 5 plus nothing common, 1 common, y minus 5. Both brackets are identical. We are good with our middle term breakup strategy. Y times y minus 5. The first bracket is y minus 5. The other is y plus 1. Y minus 5 cancelled out. I have y over y plus 1. I have y over y plus 1. Taking y common, applying middle term strategy here, 1 5 the 5, minus 5 plus 1 results in minus 4. I have written minus 5y plus 1y, minus 5y plus 1y results in 4y. Taking common, y common results in y minus 5. Nothing common, 1 common, y minus 5. Both brackets are identical. We are good to go. One bracket is y minus 5 times y plus 1. Y minus 5 cancelled out. We have the answer y over y plus 1. So option number A is our right option in that case. Moving towards another, the question f of x and g of x in fork type question. Fork. We have to find fork means composition of function, or one can write in word composition of functions. Composition of function. In that case, we have given one linear function and other one is quadratic. One function is linear, other is quadratic. We have to form the composition of f of g of x. F of g of x. F of g of x. Let's see and find out how to manage this. It's really very easy. Composition. How to deal with composition? F of x is 3x minus 1 and g of x is x square plus 1. Fork f of g of x. What's the value of g of x introduced here? It is f times x square plus 1. X square plus 1. Now it's simple strategy. If I have written here f of minus 1, instead of x, I have to switch over minus 1. I have to plug in x is equal to minus 1. Here we have x square plus 1 instead of x. Here we have x square plus instead of x. So we have to plug in x square plus 1 instead of x. How? Let's see. 3 3 instead of x I have written bracket, instead of x I have written bracket, instead of x I have written bracket, instead of x I have to plug in x square plus 1, that's our 3x square plus 3 minus 5. I have 3x square minus 2. 3x square minus 2 is our answer. In that case, 3x square minus 2 is our answer. One can easily verify in that case. Fog and golf, they are not equal, they are not commutative. Fog does not equal to golf. Fog does not equal to golf. They are not commutative. They are not commutative. Let me verify this as well. So I have the result of fog is equal to 3x square minus 2. What about golf? Let's see and find out. Let's see and find out. Golf. Fog we have calculated. Now golf. G of f of x. What is the value of f of x? What is the value of f of x? That's 3x minus 1. Instead of f of x, switch in 3x minus 5. Now here in g of x, we have to switch. Instead of x, we have to write x square plus 1. Instead of x, we have to write 3x minus 5. Here original function is x square plus 1. Instead of x, we have to plug this value. 3x minus 5 whole square. 3x minus 5 whole square. Okay, simplify this one. It is a square minus 2 times ab plus b square plus 1 same. We have 3x. Here we have 5. 3x. Here we have 5. It will become 9x square. 2 3 6, 6 5 30x plus 25 plus 1. So we have 9x square minus 30x plus 26. That's the value of golf. That's the value of golf. One can easily verify. Fog does not equal to golf. Fog does not equal to golf. Fog does not equal to golf. Fog does not equal to golf means composition of function is not commutative. Composition of function is not commutative. Is not commutative. Is not commutative. Is not commutative. Okay, we have already. Now find what is the reciprocal of 6 minus 2 times root 5. What is the reciprocal of 6 minus 2 times square root 5? 2 times root 5. 2 times root 5. A reciprocal can also be called multiplicative inverse. Reciprocal is also called multiplicative inverse. Reciprocal is also called multiplicative inverse. Reciprocal of this one. Reciprocal of 6 minus 2 times root 5. 2 times root 5. So, one reciprocal means reciprocal of this one. Reciprocal of this one. Multiplicative inverse. 6 minus 2 times root 5. Now we have to rationalize in order to get rid of square root in the 5, or rationalize. Change the middle symbol, change the main symbol, multiply as well as divide. I have 6 minus 2 times root 5 multiply by 6 plus 2 times root 5 divide, multiply as well as divide. Multiply as well as divide. Multiply 1 with 6 plus 2 times 5, it will remain same. Here the situation props difference of 2 square, a minus b, a plus b, a minus b, a plus b. So 1 times 6 plus 2 under root 5, 1 times 6 plus 2 under root 5, and here difference of 2 square, a square minus b square, a square minus b square. Here a is 6 and b is 2 times root 5. 1 times multiplication results in nothing. No change. 6 plus 2 times root 5. Square of 6 is 36. Square of 2 is 4. Square of 2 is 4. Square of root 5 is only 5. Square of root 5 is only 5. 4 times 25. Numerator same. 6 plus 2 times root 5. 6 plus 2 times root 5 36 minus 20. 36 minus 20. 36 minus 20 results in 6 plus 2 times root 5. It will result in 16. It will result in 16. Taking 2 common from the numerator, 2 has been factored out, 2 is common factor, 2 common, 3 plus root 5 over 16. Applying table of 2, 8 to the 16. So our eventual answer is 3 plus root 5 over 8. 3 plus root 5 over 8. 3 plus root 5 over 8. That's our answer in that case. That's our answer in that. 3 plus root 5 over 8. Moving towards final question, a graceful question at the end. The sum of all numbers of the form 2k plus 1. The sum of all numbers of the form 2k plus 1 where k takes on the integral values from 1 to n. K takes the integral values from 1 to n. The sum of the numbers of the form, let me open up this form 2k plus 1 where k belongs to natural numbers from 1 to n, from 1 to and 1 to n. If I put 1 here, it will become 2 times 1 plus 1, it is 3. If I put 2 here, 2 times 2 plus 1, it will result in 5. If I plug in 3 here, 2 3 are 6 plus 1, it will result in 7. If I plug in 4, 2 times 4 plus 1, it's 9, and so on. 2k plus 1 is a general form of odd numbers, odd integers. Odd integers. 2k plus 1, always odd integer. 2k plus 1 gives us odd, whatever the value of k is, whether even or odd. 2k plus 1 is odd. 2k plus 1 is odd. So we are asked the sum of all numbers of the form. Sum of 1 plus 3 plus 5 plus 7 plus 9 plus dash dash up to n times, where k takes on the integral values from 1 to n, 1 to n. This is the sum we have to find out. Mostly people are familiar with the sum of first odd natural numbers is n square. The sum of first n natural numbers is odd natural number is n square. How? Let's see and find out. First term is known as A is 1. Common difference of 2, 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, up to n. So D common difference is 2 and number of terms is n. This is A is our first term, D the common difference, Some formula for arithmetic is Sn is equal to n over 2 plus 2 times A plus n minus 1 times D. Just pulling in the value of A, N and D. I have N is N, let me keep it intact. A is R1, 2 times 1 plus N is N and D is R2. Simplify this one. N over 2 times 2 plus multiply 2 here, it will become 2n minus 2. Cancelled out, we have n over 2 times 2n. 2 cancelled out, n times n is n square. So the sum of first odd natural number, is given by n square. One can verify the sum of all even numbers is n square plus n, while the sum of all natural numbers is n times n plus 1 over 2. Let me solve these two for you as well. In that case, let me take the correct option, that's our n square. Now find the sum of first even natural numbers as well sum of all natural and unnatural numbers. Let's see and find out. Really very simple it is. Odd number, even numbers, 2 plus 4 plus 6 n times. Here A is 2, RD is 4 minus 2, 2, 6 minus 4, 2, 8 minus 6, 2, 10 minus 8, 2. Common difference is 2 and number of terms is n is equal to n. Same formula, some formula for arithmetic progression is given by n is equal to n over 2 plus 2a n minus 1 into d. Or one can utilize sum is given by n over 2 a plus l. Here A is the first term and L is the last term. One can verify, utilize this one. One can utilize this one where L is equal to A plus N minus 1 times T. Where L is equal to A plus N minus 1 times D. If we plug in here value of L, A plus N minus 1 into D, we will get the same situation. We will get the same situation. Okay, let me utilize this first in order to find its sum. Then I can also verify. I have Sn, n over 2. Our first term is 2. Our last term is n. Our last term is n in that case. What is the first term is 2, 2, and last term is n. 2 plus n. Here, what went wrong in that case? Let me verify. If I multiply this one here, what is sum of even numbers? Is n square plus n. N square plus n. N over 2 plus A times L. N is n. Okay, let me utilize this first formula, then think about the other. Okay, let's see what we have. N over 2, 2A plus n minus 1 into D. In that case, A is 2, D is also 2. Let's verify. N over 2, 2 times 2 plus n minus 1 times 2. I have n over 2, 2 to the 4 plus 2n minus 2. Here I have n over 2. Positive 4, negative 2 results into 2 plus 2n. Taking 2 common, I have 1 plus n. 2 cancelled out. I have n times 1 plus n. N times 1 plus n. It is equal to n plus n square. N plus n square. That is the sum of the first even natural numbers. Sum of the first n even natural numbers. Sum of first n even natural numbers. Let me think of integers. What is the sum of all first integers, first n natural numbers, Let me find this for you as well. 1 plus 2 plus 3 plus dash 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 up to n times is given by n times n plus 1 over 2. Let's verify this one as well for you. I have A is equal to 1. Common difference 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. So common difference is 1 and number of terms is n here. So we have Sn is equal to n over 2 plus 2a plus n minus 1 times d. Okay, n over 2, 2, value of a is 1, value of d is also 1. First term is 1, common difference is 1. First term is 1, common difference is 1. So we have n over 2, 2 plus n minus 1. Positive 2, negative 1. It will result in 1 plus n. Or one can write n times n plus 1 over 2. Or one can write n square plus n over 2. So the sum of first natural numbers is 1 plus 2 plus 3 is given by n times n plus 1 over 2. Sum of first odd natural numbers 1 plus 3 plus 5 up to n is given by n square, while the sum of first even natural numbers is 2 plus 4 plus 6 plus 8 up to n times is equal to n square plus n. One can verify or utilize these direct as well. It's my tiny effort for you guys with after the absence of 1 week owing to the continuous outages of the electricity. It's all by itself next.